Hey everyone, today we're going to talk about version control, specifically Git and GitHub, because those are the two most widely used tools today. I'm going to break this down into two parts. In the first part, I'm going to dive into what version control is and how Git and GitHub fit in. And in the second part, we're going to dive into a working example, further dig into the specifics of Git and GitHub. I'm Samir, civil engineer turned dev. If you're new here, welcome. I make videos to inspire and teach others how to build software. To start, I want to do a quick thought exercise. I promise is relevant. I want you to think of a time when you were editing a file. This file could be any file. It could be a PowerPoint file, an Excel file, maybe an essay you're writing, and you've been working on this file for the past couple of hours, maybe even a couple of days. You've put a lot of work into it and you're pretty happy with the current version. But you're also thinking there might be some changes you can make that can make it better. But you're afraid that if you make those changes and you don't like the new changes, you won't be able to go back to the version you have now. So what you end up doing is you end up creating a copy of your file. And now you're free to edit the copy and not be worried about messing up the current version. So then you make your new edits on the copy, and then you look at the copy version and the original version, and you can decide which to keep. That right there is version control. But now imagine you're doing this on multiple files and there are multiple people working on these files. This is the reality of coding, and this is where version control really shines. And that's exactly what tools like Git help us manage. So what are Git and GitHub exactly? They are tools built for version control. There are many out there. For example, there is Mercurial or SVN, which are alternatives to Git, and there is Bitbucket and GitLab, which are alternatives to GitHub. But Git and GitHub are the most widely used, so it's definitely worth focusing on those two. Git is the core tool. It is a terminal-based tool responsible for helping you manage your version control. GitHub, on the other hand, is a web interface that wraps Git. It provides a UI that makes it much easier to collaborate with others and manage multiple versions of your code. A good way to think of the difference between Git and GitHub is to think of the file system on your computer and Google Docs. The file system on your computer is like Git, and Google Docs is like GitHub. Google Docs wraps a file system structure just like GitHub wraps Git, and both provide a web interface that allow you to collaborate with others and manage the versions of your code in the case of Git, or the versions of your files in the case of Google Docs in a much simpler way. Now that we have a broad understanding of what Git and GitHub are, we're gonna jump into a working example so we can dive deeper into the specifics of Git and GitHub and really get an understanding on how to use these tools. All right, let's go. Okay, so we're gonna start on GitHub, which is the web interface that wraps Git. And the reason for that is because it's a little easier to start on GitHub because it is that web interface, and therefore we can see the different components versus Git, which is in the terminal. So it's a little harder to see the different components. So therefore we're gonna start on GitHub, and then we're gonna move to Git after we do a few things on GitHub. Okay, so right now I'm on my profile on GitHub, and if you don't have a GitHub account, you can create one for free by going directly to github.com and creating an account and picking the free version. That'll have plenty. You won't need to do any more. I personally have never paid for GitHub myself. It's more meant for organizations if you have a company or whatnot. So the free version will do just fine. And once you're here and you have an account, you can go to your profile, and we're gonna start with the first concept of Git, and that is the repository. Now, the repository is how you organize projects in Git. So you can think of repository like a directory. So in your file system, you usually create a directory to hold files or other directories that have information that's all related. A repository in Git holds a project. So you can think of your website. If you had a company website, for example, you would keep it in one repository. Maybe that repository is called the name of your company, and that would contain all the code for the website of your company. So usually that's how you structure it. Repositories are like directories because they can hold files and they can hold other directories within it. So think of repository like a directory. Okay, so the first thing we're going to do is we're going to create a new repository, and on GitHub that is easy to do by going to repositories and then clicking on new. You can then give it a repository name. Here I'm going to call it my first Git repo. My first Git repo, just as a good reference to what we're covering in this video. And then I'm just going to add the same thing for the description. My first Git repo. This part doesn't really matter. I'm going to choose public, but this just means that anybody who goes to the URL can see it. And if you keep it private, only people that have access to the account can see it. In my case, I'll keep it public so that anyone can see it. I like to add a README simply because if I add a README, the first commit will happen on GitHub directly. And I'll explain what a commit is in a second, but that makes it easier to start the repository, because if I don't add it, I then would have to add the first commit locally on the terminal using Git, which is also simple, but it's just a little quicker to just do it here. If you were not to add the README, there would be instructions directly on here telling you how you could create your first commit locally. Now I say create repository, and I have my first repository. And so we're gonna do a very simple workflow. We're essentially gonna put this into our local machine, and then we're gonna use Git locally, and we're gonna add a few things to the repository to demonstrate how one would go about using Git and GitHub. So what we're gonna do now is we're gonna move over to the terminal. If you don't know what a terminal is, I have a video that explains the basics of a terminal. It's really not as complicated as it sounds, so if you want to check that out, you can find that over here. But here, I'm just going to jump directly into it, and I'm going to run some git terminal command. Okay, so before I do that, I'm going to come here and I'm going to copy this URL, because that's going to allow me to reference my repository from my terminal. Okay, so now I'm in my terminal, and I'm currently in the file system under workspaces Samir Marin. You can see this is the path in my file system I'm in on my terminal. And what I'm gonna do is I'm gonna clone my first Git repo into my local computer. And I'm gonna do that using Git. Now, if you don't have Git installed on your local computer, I'm gonna put some info on the description in this video on how to do that. So if you don't have that, make sure you take a look at that, because here I'm just gonna jump right into it. So Git has a command that's called the clone command, which allows me to clone the repository into my local machine. And what I would do is I would write git clone, and then that URL I copied would be what I would paste in. And that's gonna place that GitHub repository into my local machine. And then I'm gonna jump into that repository. Now, like I said, a repository is like a directory. So on your local machine, that repository, the way you move into it is like you would move into any directory on a terminal on a local machine. So I would cd for change, and then I would go to my first Git repo, which is a directory. And now I am currently sitting in my terminal under my first Git repo, Git repository. And if I run some Git commands, I can see that this is a repository, because for example, if I run git status, you can see it recognizes that I'm in a Git repository. And it tells me that I'm on the main branch, which I'm going to talk about in 1 second, and that the branch is up to date with origin main. And what this origin means is the GitHub origin, so the place where we created the repository. And these are things I'll talk about in 1 second, so bear with me. Okay, so the first thing we're going to talk about here are branches. So we talked about the repository, which is like a directory, and it's where you hold your project, your code. If you had a website, you would hold it in a repository. The second part I'm going to talk about here are branches. The easiest way to think of a branch is referencing back to that example I gave where you had file and file copy, and you wanted to make sure that you didn't overwrite the current version of your file. So you made a copy of the file so you could freely edit that new copy. And if you didn't like the new edits, you could go back to your previous file. Branches are basically the same concept, but they encompass the whole repository. So you could have one branch and another branch, and they'd be copies of the whole repository. So all those files, all those directories within that repository could be referenced in different branches. So for example, right now we're in the main branch, which is the default branch. And let's say we wanted to add some changes to our repository, and we're not sure if the changes we're going to add are changes we want to keep, and we're scared that if we do it directly on the main branch, we will overwrite some code that we perhaps want to keep. And we're scared that if we change it directly on the main branch, we'll maybe change some things that we don't like, and we'll have a hard time going back to the previous version. So to allow us to make changes freely without worrying about messing up what's currently on the latest main branch, we can create a new branch that diverges from that point in the main branch. And so if we come and we run git branch, this will list all our branches. Right now we just have one. And as we saw when we ran git status, we're on the main branch and we're up to date with the latest. So what I can do right now is I can run git checkout, and checkout essentially allows us to switch into another branch. And then if we do -b, it will actually create a new branch for us to switch into. So what I'm gonna do is my first commit, and I'm gonna call it my first commit, and I'm gonna explain what a commit is in just 1 second. So when I do this, I will now have switched to a branch called my first commit. And if I run git status, you can see I'm on my first commit branch. Now, what ended up happening was, if I run git branch, is I created a branch called my first commit that diverged from main right at that point where I am right now. So we were at the latest in main, and we created a branch off main called my first commit. So these two branches right now are copies of each other. But if I was to make changes on this particular branch, which I'm sitting in right now, it wouldn't affect main because that's the previous copy. So that's what I mean. It's sort of like that example I said where you had file 1 and file copy, and then you were able to make changes to file copy without worrying about messing up file 1 in case you wanted to go back to file 1 and not keep the changes you made on file copy. So now that I'm on my first commit branch, I'm going to go and add some changes to my repository. I'm going to add some files, and that's going to all live in my first commit branch. So let's go do that. So to do that, I'm going to open up a code editor. I like to use Cursor. Cursor has a free version, but it also has a paid version. So you can feel free to use Cursor as a code editor if you like, but you can use any code editor you want really. VS Code is another one people use. That one's fully free. So the way I'm gonna come in is I'm gonna write Cursor, and I'm just gonna open up the repo, my first Git repo. Okay, so I'm in Cursor in my first Git repo, and you can see we have that README, which is what we added when we created the repository on GitHub. And that's all there is in this repo right now. And we are currently in that my first commit branch. So we're still sitting there. And what we're gonna do is we're just gonna add some HTML to this repository. So the way to do that is I come in here, new file, and I can call it index.html. The important part here is understanding the steps we're taking to use Git and GitHub as version control tools. So I have some code that I'm gonna paste into here. It's just some simple HTML, and then I would just show civil engineer turned dev. So it's just some simple HTML that you can open up, and it's really just meant to show version control. So you don't need to worry too much about the content in here. Okay, so once I have this file in here, let me show you what it looks like if I was to open this on the browser. So it's just some simple HTML that shows Samir and then civil engineering turned dev. That's all it is. Let's go back to Cursor. Okay, so once I've added this file, I then want to make sure I save my changes to my first commit branch. So to do that, I'm gonna head back to the terminal, and I'm gonna save that file into my first commit branch. So the first thing to do, and this is a very important command, is run git status, because this always tells you what's going on. So you can see that it's now telling us we have this index HTML file which is not tracked. And the reason for this is because this file was just added and Git doesn't know anything about this file. It doesn't know whether it should even worry about it. So that's why it tells us it's not tracked. So then to track it, there is a command called git add. So if I run git add index HTML, I've now told Git I want to track this file. So if I run git status, it tells me there is a new file. Now, when a file is tracked, Git is always aware of it now. So for example, if I was to go back to cursor and I was to change this Samir and add Marin to it, there are changes that happen on this file now. And because it's tracked, if I was to come here and run git status, it would actually tell me this file was modified because it's currently being tracked. And then for me to know what was modified, I can actually run something called git diff, which gives us a diff between what was there before versus what was modified. And it'll show us that there was a modification, and the difference is there's Marin. This is previously, this is now. Marin, Samir. And then another important part here is that once it's tracked, if I make changes, it doesn't mean I can save those changes to the branch right away. Because for me to say, hey, I do want these changes to be saved, I have to use this command called git add, which was what we previously did when we added the file. But what I can do now is I can say git add -p so that I can see exactly what are the new changes I'm going to be adding that will be saved to the branch. And here it tells me, okay, so this file had these changes, and if you add them, this is what the file will look like now. And I can click Y for yes, and now the file is fully added and can be saved as it currently looks in cursor when I go here. And if I do git status, I can see that I have the new file. And now the way to save this file into my first commit branch is by using a command called git commit, which I had mentioned a couple of times before. But git commit means I'm gonna actually save these changes directly into the branch, right? So before it was more just making sure I'm tracking the files, making sure that whatever was changed was added to the track. And this part here is actually saving it, and it will be saved directly to the branch by using the git commit. So when I go git commit, I can then write a message by doing -m, and then I can say quotation marks adding index HTML file. And when I do that, it's now committed directly to my first commit. And if I do git status, it tells us that we're completely clean and everything is saved. And now what this means is that I've saved that change directly to the branch, and if I was to delete it, I would have to do another save. So this is a really important concept in Git. Once you commit something, it is fully saved and there is a history of what was saved. So if I was to delete the file, for it to completely delete, I'd have to make another commit, and that would be tracked. So you would know that it was added and then it was deleted. And that is the power of version control. Each save you're doing is always tracked. And that will become a little more clear when we jump back over to GitHub, because we can see exactly all the commits that happen. So now that we're here, we can then push this change up to the GitHub repository so that we can have a better view of what exactly we have done on this branch. So the way to do that is I have another command called git push. Now git push essentially allows me to take the work I have done locally and then push it back up to the GitHub repository that lives in the web browser. And so the way to do that is we go git push, and now origin stands for I want to push it to the origin, and the origin just means the cloud repository. So I want to git push origin and then the name of the branch that I'm pushing to the origin. So my first commit. And then if I run this, what will happen is it will push it up to the GitHub repository. And then once I've done that, I can then open up this change in GitHub because it's now been pushed up to GitHub. So if I click on this here, I can go take a look at what I did. And here it's asking me if I want to open up a pull request. And now what a pull request is, this is another concept. is it is essentially something that shows new changes I want to make from one branch to another branch. So in this case, I pushed up changes on my first commit. Now you can remember that originally we had made this branch off of main, so they were copies of each other. We then made some changes on my first commit. So now there's a difference between my first commit and the main branch. And what this pull request will show us is that difference. And so when I create it, you'll see that you can see that difference, which should just be that one file we added. And here you can see that it's essentially saying, hey, if you were to take the changes from my first commit and put it into the main branch, you would be adding this one new file. And so that right there is very closely tied to what I was talking about with making a copy of your file, right? If you had my file 1 and then my file 1 copy, you would have my file 1 in this current version, and then my file 1 copy, you would have made changes to it. Now you have both copies and you can decide which one to keep. And this is essentially what this is doing. We can decide to keep my first commit and bring those changes directly into main because we like those changes, or we can decide we don't really like these changes and just delete my first commit and keep what was currently in main, which was just the readme. Now in this case, I want to keep my first commit. So if I come back here, I can merge this pull request. And what that will do is it will merge the changes that are here into main. And main will then have the changes we made on my first commit. So I'm gonna click merge, and now they're merged, and I will delete that my first commit branch because I don't need it anymore, because I'm happy with the changes I made in it, and now I've brought them into main, the main branch. And I can now go back to my terminal, and if I was to switch to main in my terminal right now, so here we are, we're still on my first commit locally. Now you may be asking yourself, I thought we deleted that branch, and that is true. Remember, we deleted it on GitHub. We have not deleted it locally, because locally we still have not brought in what we did on GitHub. They are still separated, and for us to make sure they're combined, we have to bring things in. So for example, this branch still exists even though we deleted it on GitHub. And if I was to switch to the main branch with git checkout main, and I went back to cursor, you would actually see that the HTML changes are not there. You can see that it's essentially saying I'm on the main branch. This index HTML does not exist here, right? It's just the readme because we're on the main branch. So I would have to bring in the changes from GitHub so that the index HTML exists on the main. And the way to do that is, now that I'm on the main, there's this command called git pull, and you can see as soon as we pull, we brought in the changes that we made on GitHub. The index HTML is now on the main, and if we go back to cursor, you can see the index HTML is there. And now I'm just gonna go through the workflow one more time, just so we really dive deep into these concepts and really understand the Git GitHub version control workflow. All right, so let's go back to the terminal, and let's say we want to make a new change to our index HTML file. So what we would do is we say, okay, we don't want to make the change directly on the main branch because we might not like the changes we make, so we're gonna create a new branch. And we do that with git checkout, but because the branch we're gonna switch to does not exist, we need the -b, and we'll call it my second commit. All right, so now we're in my second commit, and now we're gonna go to cursor, our code editor, and we're gonna make some changes to the index HTML file. Before that, let's run git status. We can see that we're on my second commit branch and there are no changes. It says the working tree is clean. Now we go back to cursor and we can see that we have our index HTML file, and maybe we just want to add one more line, and maybe we'll say this: I'm a civil engineer turned developer, I'm a quick learner, and I'm always looking to improve my skills. Let's add that. And now we can go back to the terminal, and if we do git status, we can see what kind of changes we have, and it tells us, oh, we modified index HTML, and we can run git diff, and then we can see exactly what we modified. Now we can open this up on the web browser to see the changes we made, just because sometimes it's easier to see things actually running. So let's do that really quickly. We can do open index.html, and then we can see, okay, Samir Marin, civil engineer turned dev. I'm a civil engineer turned developer. I'm a quick learner and always looking to improve my skills. So that's the change we added. If we like it, then we can decide that we want to add it to our current branch. And the way we do that is we say git add and then -p to allow us to see exactly what we're adding. And we can accept that or reject it. I'm gonna accept it. And now that we've added it, we can say git status, and it tells us that it's modified, but it's been added. So that means if it's been added, we can save it directly to the branch. And the way we do that is with git commit, and we can say a message for the commit with -m, adding more info to index.html. And then once we do that, we press enter, and then we run git status again. We can see that we're clean, meaning that we've saved it, and we can then push this up to GitHub again. And we can say git push origin, my second commit, and this will push it up. And then we can click on this to view what we just pushed up and see if we want to bring it into the main branch. So here we are. We can create that pull request, which is what it's called when we want to see what exactly we're bringing in from this branch into the main branch. We create the pull request, and then we can look at the files, and we can see that this is the change we added. And once we've done that, we can then decide to either bring it into main, or we don't want the change. We can also decide that we don't want to merge it into main, and main will stay as it was before without this second line. So if we do decide we want to bring this into main, we can say merge pull request. We can confirm the merge, and once we've done that, we have added that change into the main branch. And if we go back to the main part here where it says code, we can see we're in the main branch, and we can see that this index.html file is in the main branch. And here we can see everything, including that line we just added. And then, as I had mentioned before, commits are very important because they're always tracked. So you know exactly what happened in the history of that particular branch. If we go back here into code, we can see that there is 5 commits, and we can see exactly what has happened to this branch. We can see the initial commit, which was when we added that readme, when we created the repo. We can see the first time we added the index.html file. We can see that first merge, which is actually considered a commit as well, and that's when we merged my first commit into the main branch. We can see when we added more info into the index.html, which was that second line we just added, and we can see when we merged that my second commit into the main branch, because we're looking at all the changes happening on the main branch. And that is version control and a little bit of how Git and GitHub work. And I think this gives you enough to get started. And you can imagine how helpful this may be if you're working with multiple people. Multiple people could be making changes on their local machines. They could then be making those changes on a completely separate branch and then pushing them up to GitHub. And then there, everybody can look at the pull request, which is what it's called, when you want to bring in a change into the main branch, and decide whether those changes are changes you want to add to the main branch or not add. So that's the idea of the pull request. You can have multiple people look at it and approve whether those changes are wanted or not wanted. So GitHub makes that very nice and very easy, so you can collaborate with a team of developers when you're making changes to repository code. And then you can see the power of being able to track every single change that happened with the commits, because that gives you a direct history of everything that has happened. And by having that, you could also decide, hey, this change actually was something we didn't want, and you could go in and remove that change. It's a little complicated to do that, but it's a possibility because everything that has happened in that branch is tracked at every step of the way. So there you have it. That is version control and how Git and GitHub fit into the picture. If you like my content, you can find more of it over here, and I will catch you on the next one. Bye-bye.